All right, we are going to do a quick recap of different division, and then we'll get into 5.5. So 5.5 is going to really focus on synthetic division and what it does. But just as a reminder, I want to do one more long division and then do it side-by-side synthetic division so you can practice each process so you are ready for this section. So this one is asking you to do a long division and a synthetic division. So I'm going to kind of split screen here, and I'm going to put the long division on the left, and I'm going to put the synthetic division on the right. So with the long division, you do want to check for placeholders. You want to do that for both. We have nothing missing here, so we're going to go x to the third minus 8x squared plus 17x minus 10 and divide by x minus 5. So the process is you want to see what I multiply x by to get it to be x to the third. So that's going to be an x to the second. You want to keep your columns lined up. So I'm going to put an x to the second there. You then multiply through that x to the second. So x to the second times x is x to the third. And then x squared times negative 5 is negative 5x squared. You then subtract, and I love to do a different color pen so you can see that. So this becomes a negative, this becomes a positive, which will cancel out this term. So negative 8x squared plus 5x squared is negative 3x squared. And then you drop down your next term and repeat the process. So we figure out what I multiply x by to get it to be a negative 3x squared. So that's going to be a negative 3x. Multiply that through, so we get negative 3x squared. And then a negative 3x times a negative 5 is a positive 15x. Change signs, so I'm going to switch colors again. That becomes positive, that becomes negative. So I get 2x, drop down the negative 10. So now I want to see what I multiply x by to get it to be a 2x. That is going to be a 2. So I multiply through, I get 2x. 2 times negative 5 is negative 10. Change signs to subtract. And that cancels this. We end up with 0 remainder. So my answer, my quotient, is this entire polynomial. And since it has a 0 remainder, we would say that x minus 5 is a factor of this polynomial. Doing it as synthetic division is much faster. So we write up our little table here. We put our coefficients across the top. So 1, negative 8, 17, and negative 10. You're going to put what makes this equal to 0 outside. So 5 goes outside. Drop down the first one, multiply, and then add, multiply, and then add, multiply, and then add. And these values represent your answer. You have 1x squared minus 3x plus 2. So the idea here and where we're kind of headed in this section is we're really going to focus on the ones that do give us a 0 remainder, the ones that are factors, because we're going to use this idea to look at graphs of functions and figure out when it crosses the x-axis. So the goal in 5.5 is going to be to do the synthetic division. We're going to kind of step away from long division to be able to prove if a number is a root or a solution of the polynomial. The way I prove that is by going through this process of synthetic division and showing that I get a 0 remainder. That means that the number that I divided by is going to be a root or a polynomial. It means visually it's going to be where it crosses the x-axis. So if you go back to this one we just did, since we said that 5 was the 0, and we did this processing, we got a remainder of 0, that tells me that x equals 5 is a root or a solution or an x-intercept, they all mean the same thing, of this polynomial. So if I were to graph that polynomial, I would see that it would cross the x-axis at 5. So that's kind of where we're headed. And we're going to be using the synthetic division entirely in this section to be able to prove solutions and to be able to find solutions. So that just gives you a little preview of coming attractions of what this 5.5 is going to be all about.